Alright class, this is Brian. Mr. Win asked me to help him out again because apparently Mr. Win sucks at time management. So he wants me to do these problems with you guys because he can't do it for you. So we're just going to do the circle ones, okay? So remember, the homework is finishing both sides of the worksheet. All the answer key is on Canvas, okay? So if you need to check your answers to reassure yourself, please check on Canvas. But I'm just going to give a bit more explanation on these problems here. So let's jump into number 5. We're on this page, okay, with this beautiful diagram right here. Oh shoot, I need to reconnect my Apple Pencil so I can write on the screen. Right, is it working? Yay, okay. All right, we're on this side. Numero 5. Write or name the definition or theorem that justifies the statement. Just a side note, before you do this worksheet, you're supposed to fill out the whole entire vocab sheet. Right, it has all your vocabulary in it. Okay, so make sure you do that. So for this case, if AE is perpendicular to FC, where's AE? AE is perpendicular to FC, boom. Then angle AFC, where's AFC? AFC right here, boom, is congruent to EFC. So what does that mean? You're basically translating this into your theorem, the whole phrase. So this theorem is perpendicular lines form congruent, so they're equal, right? Equal in size and shape. Congruent adjacent angles. Remember, adjacent means next to. So basically, this perpendicular line, right? These perpendicular lines right here, they're always going to form congruent adjacent angles, which, by the way, are 90 degrees, right? So that's that one. Number 9 and 10, these are pretty simple, but they're just very strict definitions, okay? Looking at 9. If angle BFD, where's BFD? I'm going to erase this. BFD. BFD. Right here. Okay, angle is BFD is a right angle. Bam. Then FB and FD, FB and FD are perpendicular. Okay? This one right here, anytime you see right angles and perpendicular, this one's going to be definition of perpendicular lines. Okay. If they're a right angle, then these are perpendicular. Okay, and that's simply because that's the definition. Okay, the definition of perpendicular lines is that they form right angles. Number 10. If EFC, where's EFC? EFC, KFC. Just kidding. AFC. EFC right here. Boom. That's the right angle. So if it's a right angle, then it's 90 degrees. Right? This one is your definition of a right angle. Okay? So the official definition of a right angle is that it forms a 90 degree. The official definition of a perpendicular is that it forms right angles. So forms right angles. Right angles. And this one forms 90 degrees. Okay? That's like the official definition process. Numero 11, AFC is congruent to CFE. Where the heck is that? AFC. AFC. Oh, okay. Seems like we're doing the same thing as before. CFE. Boom, this is CFE right here. So this is just the converse, actually, of number 5. Right? They're the converse of each other. So this one would be if two lines form congruent adjacent angles, then the lines are perpendicular. Oh, that's a lot. Essentially, it is the converse of this. You're just switching those two statements. Okay, that's what that means there. But yeah, don't worry too much. Like this as a theorem, you don't actually use it in a proof. But just kind of know that that statement there is always true. But know that it's not really used in proofs a lot. Okay, so number 12. Okay, I'm going to do this proof. This is like the black market proof. Okay, so you guys don't have this. This is actually just a 4-step proof. But we're going to practice 2 ways. It can be an 8-step proof. Wow, look at that. It can be an 8-step proof, which is this is what you have on your canvas, on your key, which you can find on Canvas. This one will probably make more sense to you. Okay, so please understand this method. I would do this in class as well. But if you're a scholar and watching these videos, this is the black market proof. Okay, so I'm going to do this 4-step one real quick. So let's try to understand the diagram first. CD, AB, boom, perpendicular. Okay, the perpendicular. Angle 1 is congruent to angle 4. Just kind of mark that up right there. Bam. You try and prove 2 is congruent to angle 3. So this is a quicker way to do it. This is given, we know that. Alright, so this actually skipped a couple of steps. So draw a little, don't fill this out completely yet. So remember, when you're given perpendicular lines, your next step is to say, your next step is to say that the angles are right angles. But this kind of jumped a bit, so let's see what they do here, okay? Angle 1 and angle 2 are complementary, okay? So angle 1 and angle 2 are complementary because they're assuming they add up to 90, right? So this here is your complementary theorem. Or you can put definition of complementary angles. So either or. So same thing for step 2 there. But they did skip some steps, right? This is why the other one, they skipped steps. Because technically speaking, they're supposed to state that it is a right angle. Then you state that they're 90 degrees. Then you say that they're complementary. That's the true proof process, complementary. Alright, you guys see this process? You have perpendicular lines. You go from perpendicular to right angles. What does right angle mean? It means that they're 90. What happens when they're 90 degrees? Well, we call them complementary. So this here is, this process is done with the 8 steps here. So please check that out. It's very important to understand our process. But I'm just going to show you a little shortcut from the textbook as well. So what they're trying to get at, do we see how angle 1 is congruent to angle 4, right? This was given, right? So angle 1 is congruent to angle 4. Okay, that's your given step. And all they're doing here, since angle 1 and angle 4 are congruent, well, if they're complement to the same angle, then those angles are congruent. So like, do we see how angle 2 is complement to angle 1? Angle 3 is complement to angle 4. So if those two angles are complements to the same angles, then those are congruent. And when I say same angles, that means because they're congruent anyways. So this here is your congruent complement theorem. Congruent complement theorem. Okay, that's like one of the shortcuts here. Hope you guys kind of understood that. If not, I'm not really a fan of this way either because it kind of skipped a couple of things, which is why I checked Canvas for the other 8-step one. Okay, flip over to the back real quick. Back. This one? Yeah, this one. I'm just going to do 6 and 7, okay? Because I don't think I went over 6. Let's just look here. Name or state the definition, postulate, or theorem that justifies the statement about the diagram. If FC, this is FC right here, bisects AFE, AFE is right here. Bisects, remember the word bi means two, sex as in sections, so it splits into 2 sections. Right, it splits angle AFE, the one in blue, into 2 sections. Then angle AFC equals 1/2 of the measurement angle AFE. This here, I don't think I went over this. Or I mean, I don't think Mr. Wynn went over this. So this here should be angle bisector theorem. I think it's in the key though. We'll probably go over this on Monday. Angle bisector theorem. Basically, this is just like your midpoint, right? But your midpoint is for segments, right? Midpoint is like, you know, it's in the middle. Angle bisector is in the middle of angles. That's why number 7 here, if B is the midpoint of AC, B is the midpoint of AC, then BC equals half of AC. This is your midpoint theorem, or definition of midpoint. Or you can put definition of midpoint. Okay. And again, with angle bisector, all right, you're literally just cutting it in half, right? So boom, you just cut the angles in half. These are congruent now, right? That's your angle bisector. So it's just like for midpoint, but midpoint are for segments. Angle bisectors are for angles. All right, good luck with the rest. Just do your best. You do have the key as well. And Monday will be a all question type of day, all right? Have a good weekend, guys.